Ever feel like someone hit the turbo button on your brain? Like it's trying to process a million things at once? Well, buckle up, because today we're diving headfirst into the deep end of brain science. Seriously, the source material for this deep dive, it's like peeking into the future of neuroscience.
Oh, tell me about it.
We're talking about a dense academic paper, and the title, get ready, The Rise of the Posthuman Brain, Computational Neuroscience, Digital Networks, and the In Silico Cerebral Subject. I know, it's a mouthful.
Quite a mouthful.
But stick with us, because this deep dive, it's your decoder ring for understanding not just where brain science is going, but the huge questions it's raising about what makes us human.
It's a real shift in how we think about the brain. I mean, for centuries, we were limited to studying the physical stuff, the cells, the anatomy, all that. But now we're talking about the brain as information, patterns, processes, things we can actually start to map and measure with incredible detail.
Okay, so less scalpels and microscopes, more like algorithms and simulations, right? It's almost like we're trying to crack the code of the brain.
That's a really good way to put it. Think of it this way. We have this mountain of data about the brain now, but making sense of it, connecting the dots, that's the real challenge. And that's where computational neuroscience comes in.
So walk us through that. What's computational neuroscience? I feel like it's one of those terms that gets thrown around a lot.
It is, and it can sound intimidating,
Yeah.
but it's really about using the power of computers to make sense of the brain's complexity. It's like, imagine you have a library with millions of books, but no system for organizing them, no Dewey Decimal System, total chaos. Computational neuroscience is like creating that system, building the tools that let us navigate and understand the vast landscape of the brain.
That makes perfect sense. It really highlights just how complex the brain is. But if we're building these digital maps, these simulations of the brain, what does that actually look like?
Well, this paper talks about something called the Human Brain Project. Imagine trying to build a working simulation of a human brain on a supercomputer. That's exactly what they're trying to do.
Wow, a digital brain. That's a lot to process. But how does this all connect to the idea of a post-human brain? This paper keeps using that term, and honestly, it makes me think of robots and AI taking over the world.
It's easy to go there, right? All the sci-fi scenarios. But what this paper's getting at is way deeper than that. It's not about turning into robots. It's about recognizing that our brains, even in their natural state, are already incredibly complex information processors.
Okay, so less about becoming post-human, more about understanding that we already kind of are in a way.
Exactly. This post-human idea is about shifting how we view the brain itself. It's less about the physical stuff and more about recognizing those patterns, the processes, as the core of what the brain is.
And I'm guessing that if we can understand those patterns, the next step is figuring out if we can manipulate them, even enhance them.
You're catching on quickly. It's not necessarily about becoming more than human, but understanding what makes us human in a completely new way.
Which, as you can imagine, opens up a whole new can of ethical worms. Like, if we can fix a brain with this technology, could we also upgrade it, give someone superhuman intelligence or something?
That's exactly the question this paper wants us to consider. And trust me, it gets even wilder from here.
Right. Like, where do we even begin to draw the line?
Well, that's the thing about this whole shift from biology to information. It changes everything.
Yeah.
If our brains are basically just information processors, theoretically, there's no reason we couldn't tweak them, make them faster, more efficient.
Okay, now I'm picturing like every sci-fi movie where humans get outsmarted by their own creations. Are we really talking about a world where some people have these enhanced brains and others don't? What happens to fairness, equality?
It's a huge question.
Right.
And this paper isn't shying away from it. It's not saying we should do these enhancements. More like, hey, if this becomes possible, we better be ready. Because it could reshape society in ways we can barely imagine.
It's kind of both exciting and terrifying, you know? Like we're standing on the edge of something huge but have no idea what's on the other side.
And this paper goes there. Like
Yeah.
really far out there. One of the wildest things it talks about is this concept of substrate-independent minds. Ready for this? It's the idea that consciousness, like our very sense of self, might not actually be tied to our physical brains.
Hold on. You're saying our minds could exist outside our bodies?
That's the theory. The paper suggests that if we can really crack the code of consciousness, those information patterns, we might be able to upload it to a different system. A supercomputer, maybe.
Oh, okay, we're in full-on sci-fi mode now.
But that's the point. What seems impossible today might be totally normal in the future. And this paper is a wake-up call, telling us to think about these possibilities before they become reality.
So we're talking about potentially boosting our brains, maybe even existing outside our bodies. It's all very matrixy, but there's this other side of it that keeps nagging at me. If our brains become more like computers, aren't we also risking becoming less human in the process?
It's a valid point, and the paper touches on this idea of the agency of the non-human. As we depend more on technology, on algorithms especially, we have to ask ourselves, how much control are we actually giving up?
It's like I was saying before about algorithms shaping what we see online, what we read, what we listen to. It's almost like some of our choices are being made for us already.
Exactly. And as we lean on these computational tools even more, the line between our own choices and those made by algorithms gets blurrier. It challenges our whole idea of free will.
So we're potentially enhancing our brains, maybe even existing outside of our bodies, but at the same time, we're risking losing some of our autonomy, our very sense of self. It's a total mind bender.
A paradox. And that's the thing about this paper. It leaves us with way more questions than answers. But those questions are crucial to grapple with.
This deep dive has been intense. We went from dissecting brains to simulating them, from enhancing our abilities to maybe even uploading our minds. It's a lot.
It really is. But what's clear is that computational neuroscience is pushing the limits of what we thought was possible. And as we step into this unknown territory, we have to be incredibly careful, ethically speaking.
It's like we're at this crossroads. One path leads to incredible progress, and the other, well, who knows what consequences are waiting down that one.
And that might be the biggest takeaway from all of this. This isn't just some abstract science debate. It's about the future of humanity. And we all need to be part of this conversation, asking the tough questions, making sure science and ethics go hand in hand.
I'm feeling a little sense of urgency now, like we need to start figuring out these ethical dilemmas yesterday.
It's never too late to start asking the right questions. And this paper gives us a good starting point.
Okay, so as we wrap up this part of the deep dive, I'm curious, what really stuck with you from all of this? What's the one thing you can't stop thinking about?
For me, it's this idea of the in silico cerebral subject, this digital model of the human brain. It's like a mirror showing us not just what we are, but what we might become.
A digital reflection of our minds. It's a powerful image. And yeah, one that'll stick with me for a while, I think. It makes you wonder what it really means to be human when we're talking about this level of technology, you know? If we can create these digital versions of ourselves, these in silico, whatever they are, does that change how we see ourselves? Like, do we start blurring the lines between real and virtual even more than we already have?
Big questions, right? And the paper doesn't pretend to have all the answers. But one thing's for sure. We're in a whole new world of understanding the brain, and with that comes a lot of responsibility.
It's like we've been given the keys to the most powerful engine ever, but haven't quite figured out the steering wheel yet.
And like any powerful tool, there's always the risk of misuse. That's why this ethics conversation isn't just some side note. It's got to be at the heart of everything we do in computational neuroscience.
It's almost like we're writing the rule book for a game we're only just starting to play.
With incredibly high stakes. The decisions we make now, they don't just affect this field. They could affect the future of humanity. No pressure, right?
So where do we even begin? What can we, just regular people, do to make sure this technology is used for good?
Honestly, I think the most important thing is to stay in the loop. Keep asking questions. Don't let the scientists and politicians have this conversation behind closed doors. We need transparency, public dialogue. This has to be a team effort if we want to shape a future we can all feel good about.
It's about taking back some of that control we were talking about, right? Making sure technology serves us, not the other way around.
Exactly. And that starts with knowledge, helping people understand these complex issues so they can join the conversation.
Which is exactly what we're trying to do here, even if it means leaving you with more to think about than when you started.
Sometimes asking the right questions is more valuable than having all the answers. That's what drives progress and keeps things moving in the right direction.
Couldn't agree more. This deep dive has been quite the journey. We've gone from looking at brains to trying to build them, talked about boosting our minds, and maybe even uploading them.
It's a lot to wrap your head around.
It really is. But I hope it's also sparked some curiosity, some sense of awe about what the human brain is capable of.
Absolutely. Because even as we dive deeper into this digital world, we can't forget the power and the mystery of our own minds, what makes us human in the first place.
Well said. So, as we wrap up this deep dive into the post-human brain, just remember, Stay curious, stay informed, and never stop asking those big questions.
The future's not set in stone, and we all have a hand in shaping it.
Thanks for joining us, and until next time, keep those minds open and those questions coming.